Hello everyone. The title of today's lecture is Relation. What is a relation? Basically, we'll try to understand today. So, in order to move forward to today's lecture, we require some prerequisites, that is some prior knowledge which we already know. The first is the Cartesian product and second is subsets. So, in order to get a good clarity of what this relation is, we first need to know what are these two informations. So let's move forward today into the lecture. One more point we're going to understand in addition to the relation is this arrow diagram, what it is, what the role it plays. So let's first try to understand what is a relation. Taking two sets basically. The first one is, let me take a set A, or let A to be a set consisting of elements, suppose say small f, small c and b. Likewise, the set B which I am taking, consider the set football, so these two sets I have taken. The Cartesian product between these two sets A and B is given by this notation A cross B and is given by collecting the ordered pairs A comma B, where this first element A is coming from the first set capital A. Likewise, the second element is coming from the set capital B. Now, we can make a good observation. The set A which we have chosen, in the elements in the set A, basically if you observe here, the small f is nothing but the first letter of the game football. Likewise, the small c is the first alphabet of this keyword cricket, and finally the small b is the first keyword of the keyword badminton. So can I assign a kind of a relation between them? We talk of this Cartesian product now here, which we have defined A cross B, which is given by the collection of these ordered pairs. Then of course we know that the number of elements in the set A cross B will be number of elements in the set A times number of elements in the set B, which is 3 times 3, and which is of course 9 in our case. The relation which we want to define is basically what I want out of these 9 ordered pairs. I want to pick some of them which satisfy the relation between the elements of these two corresponding sets. And the relation which I want, which we can make by making just a simple observation, that these elements small f, small c, small b are the first word of these keyword football, cricket and badminton respectively. Fine. So now if I collect only those 3 ordered pairs, what I am asking now, you collect only these 3, f comma football, this is the first order pair which I want to collect, c comma cricket and b comma badminton. So I am interested in collecting only these 3 ordered pairs out of these 9. I'm just choosing these 3. Fine. In the Cartesian product there are 9 ordered pairs and we have taken just 3 out of them. So, and the relation how we have collected these, that the first element of this ordered pair is the first alphabet of the respective keyword in the set B. Now in the language of mathematics, I can write it more precisely, and one more observation you can make is that this set is again a subset of my A cross B. Now if you will observe here I have find the Cartesian product. This will be the resulting set consisting of 9 ordered pairs. We have chosen only these 3 ordered pairs out of the given set, and which is of course a subset of the original set. Now how we have chosen, basically I have defined a relation which I will have to introduce by this notation capital R. And how this is defined, this is the notation which I am using for the notation how I want to define this relation. If you observe, I'm calling this set which consists of these three ordered pairs as my R. I'm calling this set as my R, and how these now the elements of the ordered pair related to each other, and how I have collected is I have collected those A comma B such that this A fine. So how I have defined a relation between the element of these sets is this first element of each ordered pair is the first word of the respective keyword or element from the set B. Here small f, if I have written small, so small f is the first alphabet of this football. Similarly, small c is for cricket and small b is for badminton. So this is, I have now assigned a kind of this relation I have introduced by collecting all these ordered pairs, and this is the property which these ordered pairs satisfy. So in general, now we have built enough motivation required to define a relation between two sets in general, any two non-empty sets A and B. So now I will be defining the precise mathematical definition of a relation. Just one observation I want to make again, that this R collection of these ordered pairs which are coming from our original A cross B is a subset of my Cartesian product. So this is a good observation which will be requiring while now when I am defining the definition what is a relation mathematically. Now I am defining the definition of a relation. So definition. A relation R, whenever I am asking a relation, I will be using this R between any two non-empty sets. This is a good requirement. Is defined as a subset So this is the definition. This is a relation R between any two non-empty sets A and B is a subset of the Cartesian product. It's a subset of the Cartesian product. You first make this set and collect a subset out of this Cartesian product, and that set I'm calling this capital R, and this capital R, and now this, how note here, there's a good remark there. This remark I'm calling that capital R is defined in such a way that it exhibit basically it shows a relationship between the elements We can now rub this. We have understood this one. AB, where this A is the first element, this B is the second element. Fine. So these two elements are now related by that relationship capital R, and there's a notation again which comes into the picture, which we're going to use, and how we write that these two elements A and B are related by this relation capital R. Fine. So this is the mathematical definition of a relation. One more concept we'll try to address: arrow diagram. What is that arrow diagram? So I am taking that same example which we have just taken in the very starting to build the motivation required for relation. Now let's try to understand what is an arrow diagram. So if now I sketch these two, let me call this it's a kind of a representation for the elements of the set. This is my set, I am calling it, suppose say A, this is my set B. Now if I choose the same set which I have taken in the previous case, or we can extend the set just to make a clarity. If F, C, B, here it was football, we can it's in our hand how we want to write the elements. The order is not important here. So I can write it like this: badminton, cricket, baseball, and some more. You can take any other sports you want. You can add some more sports like hockey. So now I'm talking in general. So this, if I map my element small f with football using this arrow, similarly like C for cricket, B for badminton. Basically, if when we are saying arrow, so they should be straight, because we are talking of arrows. We can rub this one. Yeah, it's much better. So B for this, for badminton, using this notation that I'm mapping, I'm basically considering these two elements, small b and this badminton, simultaneously in an ordered product which satisfy the relation that this is the first element of first word of this keyword badminton. I'm assigning this B with this keyword badminton, and the assignment is done using an arrow like this. Similarly, finally, if I assign my C with cricket, now the resulting diagram which I got is called an arrow diagram, and it is not a matter of concern. It is not important right now if some elements are left over here. And one more important point, that on the first set, if there are some more elements, assign those elements to the elements from set B, or this is the particular example which we have taken in general. When I'm talking just of an arrow diagram in context of a relation, you can assign this element C more than once. Like here you can make an assignment again like this one. So such a diagram when we got is called an arrow diagram. And just to make a good clarity, that the diagram which I made previously when I haven't joined my B with hockey and C with baseball, that particular diagram I made in context of the relation capital R which I was defining. So such a diagram is called an arrow diagram. Fine. So we have completed the outline of the today's lecture, and in the coming lecture we'll be discussing the three fundamental concepts of domain, codomain range, which will be required in order to build a good motivation for the second keyword of our chapter, which is function. It's a very important concept throughout the course, which we're going to study, as well as like all of the mathematics. Function plays a very important role. So in the coming videos, we'll be going to study functions. Important information that in the description link there are some good reference links. Go through those links, and do like our Facebook page in order to get a good regular notifications, and also do subscribe the channel. Thank you so much.